In this video, we'll learn how to build a web application that uses text-to-image generative AI technology. Specifically, we'll work with Google Cloud's Imagen model, which is a powerful text-to-image diffusion model that's available through an API. This makes it very easy to integrate into web applications. Our project will be a Flask-based application that runs on Google Cloud's primary Docker runtime. The main goal is to show you how to integrate this text-to-image model so that users can visit our website and create custom, dynamic image content right in their browser. We'll focus on the core concepts so that you can reuse this architecture with different clouds and different use cases. Let's start by going to Google Cloud and creating a new project. Once we have our project, we'll navigate to the Vertex AI page and then go to the Vision section within Vertex AI Studio. This is where we can experiment with different text-to-image prompts, which is very helpful for understanding what kind of prompts work best before we build our web application. In the Vertex AI Studio interface, you'll notice we have several controls available. We can adjust the aspect ratio of the images we generate, choose how many results we want to see, and use something called a negative prompt. A negative prompt is interesting because it lets us specify what we don't want to appear in the generated image. After trying some prompts, you'll see that the model can create some impressive image generations. Now, to use this in our web application, we need to access the model through an API. Fortunately, Google provides detailed documentation for this, including example Python code. Before we build the full web application, we'll test this example code to make sure we understand how it works. While you can use whatever IDE you prefer, we'll use the Cloud Shell editor for this demonstration because it makes authentication easier when developing our application. Let's look at the example code from the documentation. We can simplify it a bit. If our project is already set as the default, we can remove that part from our code. We'll need to provide a prompt and specify where we want to save the output file. The model gives us many controls over image generation, but there are some limitations. For example, we can't generate images of people. We'll also set the aspect ratio to 16:9, which will work better for our web application. There's even an option to remove the AI watermark from the generated images. After making sure our project is properly set, this is important so the model knows which project to use for generation, we can run our test. Our first successful generation creates an image that's about 1.5 megabytes in size, and when we check the result, it looks quite good. Now that we have our basic tests working, let's expand this into a complete web application. We'll start by reorganizing our code. First, we'll rename our test file to app.py since we're creating a Flask application. We'll create a more organized structure where we'll store our generated images in a specific static folder. We'll also need to create an index.html file that will contain our front-end code. Let's build our Flask application step by step. The first thing we'll create is a function that handles the image generation and returns the results. This function will do two important things. It will create a unique file name for each generated image, and then it will run the actual text-to-image generation process using the GenAI model. After that, it returns the file name of the newly created image. Next, we need to create an application route in Flask. This route will be quite simple. It just needs to render a template that shows both the generated image and any error messages that might occur during the generation process. For our front-end interface, we'll create an index.html file. To save time in the demonstration, we'll paste in the prepared HTML code rather than typing it out. This HTML file has three main parts: some header content that includes CSS styles, the main HTML body that contains a form where users can enter their prompts, and sections to display any error messages and the generated image. Once we have all these pieces in place and have installed Flask along with the other required libraries, we should be able to run our application using the command python app.py. However, when we first try to preview our web application, we notice we're missing some important components. We need to fix a few errors, including specifying the configuration for our upload folder where the generated images will be stored. After making these adjustments, we can test our application again, and this time we see our success. A perfectly generated image of a dancing penguin appears. This confirms that our basic web application is working correctly. But we want to go a step further and show you how to deploy this application on Cloud Run. Even if you plan to host your application differently, understanding these deployment concepts will be valuable. In a production environment, you would typically use infrastructure as code tools like Terraform to deploy your Cloud Run service, which would result in a lean configuration consisting of just the necessary Cloud Run resources. Let's continue with the deployment process. For demonstration purposes, we'll handle the deployment through the Google Cloud Console rather than using automation tools. The first step is to set up an artifact registry repository that will store our Docker image. Think of it this way. We have our application code, and when we build it into a Docker container, we need a place to store that container. That's what the artifact registry provides. When we first look at our artifact registry, it's empty. Our next step is to create a Docker file. Since the Docker configuration isn't the main focus of this tutorial, we'll use a prepared Docker file rather than creating it from scratch. The Docker file starts with a base Python image, installs our necessary dependencies, creates the required directories for our application, and specifies how to run the application. We'll also need a requirements.txt file that lists our dependencies, particularly Flask and the Google Cloud AI Platform libraries. After creating these files, we can build our application into a Docker image and push it to our newly created repository. Once the image is successfully built and pushed to the artifact registry, we can use it to deploy our service in Cloud Run. Let's go to the Cloud Run section of the Google Cloud Console and select the container we just pushed to the registry. For testing purposes, we'll allow unauthenticated invocations, which means anyone can access our application. In a production environment, you might want to add authentication requirements. One important aspect of our deployment is data persistence. We want to make sure our generated images are accessible across all container instances. To achieve this, we'll create a cloud storage bucket. This bucket will store our generated images and make them available to all containers running our application. Once we have our storage bucket, we need to mount it to our application. The mount point will be in our generated images path, specifically at app static generated images. After configuring this, we can create our Cloud Run service. However, when we first try to deploy, we might notice the service is stuck. This usually indicates there's an issue, and in our case, the health check isn't working. There are several things we need to fix. First, we need to update the permissions for our cloud storage bucket. Since we're using the default Compute Engine service account to run our service, we need to make sure this account has the right permissions to access our storage bucket. We'll grant it storage admin permissions. Even after fixing the permissions, we discover another issue. Our container is trying to run on port 5000, but the health checks are looking at port 8080. This mismatch is causing our deployment to fail. We need to align these ports. Finally, we need to make one more adjustment. We need to ensure our application isn't just listening on localhost. We'll set our host to 0000 so it can accept connections from anywhere. After making these changes, we need to rebuild our Docker image, push it again to the artifact registry, and redeploy our service. After these 3 rounds of fixes, our service finally comes up successfully. We now have a working HTTP endpoint where users can access our application. When we test it out, everything works perfectly. Users can enter prompts and receive generated images through our web interface. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. We'll include all code and the diagram file in the description as well. If you have any questions, please post them in the comment section and we'll do our best to respond. Thank you very much for watching to the end, and please enjoy responsibly.